value of the variable is 2 and the ordered element is 4. So whatever the value of the variable, you are going to solve from the value to the given number of elements. So in this example, our first step is we are going to substitute the values of so 7 times 2 minus 1, 7 times 3 minus 1, up to 7 times 4 minus 1. So 7 times 2 minus 1 is 13. 7 times 3 minus 1 is 20. 20. 7 times 4 minus 1 is 27. 13 plus 20 plus 27 is equals to, so 13 plus 20 plus 27 is equals to 60.
So 60 is our final.
In our second example, we are going to construct sigma notation. So we have 3, 5, 7, 9, and 101. So with the help of this formula, we are going to identify, or we can construct sigma notation. So first, we're going 8. This is 3. The difference is 5 minus 3 is 2. We're going to distribute this to 2. So n times 2 is 2n. Negative 1 times 2 is negative 2. Then let's factor it out. So 2n plus 3 negative 2 is equals to 2n plus 1. So we put our last element so we can determine what order it is. So 101 minus 1 is equals to 100. We just have to copy the second, the 2n there, and divide both sides by 2. 100 divided by 2 is 50, and 2n divided by 2 is n. And we can construct our sigma notation. First, we put a sigma symbol, put the ordered element, which is 50, and our final answer, the 2n plus 1, and our n is equals to 1.
In this video, we're going to focus on evaluating trigonometric functions given an angle. So let's begin.
Let's say we have a given angle of 150 degrees and it is in quadrant 2. Its coordinates in a unit circle is negative square root of 3 over 2 and 1/2. Since it is in quadrant 2, always remember that the sine and the cosecant will always be positive. So now let's find its sine. So sine is the y, so it's 1/2. The cosine is the x, so negative square root of 3 over 2. The tangent is y over x, so y 1 over x negative square root of 3. So now let's rationalize this. So the answer is negative square root of 3 over 3. Now the cosecant is the reciprocal of the sine. So since it is in quadrant 2, it is positive. So answer is 2 over 1, or simply 2. The second is the reciprocal of the cosine. So the answer will be 2 over negative square root of 3. Now let's rationalize. So the answer will be negative 2 square root of 3 over 3. The cotangent is the reciprocal of the tangent, so the answer will be 3 over negative square root of 3. So let's rationalize. The answer will be negative 3 square root of 3 over 3.
We're given an angle of 30 degrees. So in a unit circle, the coordinates of 30 degree is square root of 3 over 2, which is the cosine, and 1/2, which is the sine. So now, let's input them in the 6 trigonometric functions. So sine 30 degree is 1/2. The cosine, square root of 3 over 2. Tangent, y over x, 1/2 over square root of 3 over 2. Cancel, cancel. 1 over square root of 3. Let's rationalize it. Square root of 3 over 3. Then, the cosecant, 2 over 1, or simply 2 over second, is 2 over square root of 3. Then, let us rationalize it. Over 3. Next, our cotangent is square root of 3 over 1, or simply square root of 3. Let's assume that we're given a point of negative 4 and 6. So, this is our negative 4, and this is our 6. So, there is one missing, the hypotenuse. So, let's use Pythagorean theorem. Negative 4 squared is equals to 16 plus 36 is equals to square root of 52. Now, our hypotenuse is square root of 52. So now, let's go to the 6 trigonometric functions. So, this is our adjacent, this is our opposite, and this is our hypotenuse. So, the ratio of the sine theta is opposite over hypotenuse. So, that means it is 6 over square root of 52. Then, let's rationalize it. Next, cosine adjacent over hypotenuse. Let's rationalize it again. Then our tangent opposite over adjacent, that means it is negative. Then cosecant 6. Our cosecant, our cotangent. The only positive there is sine and cosine since our terminal side lies on the quadrant 2.
We have a given of negative 9 and negative 12. The first thing that we're going to do is to plot it out. Since it is negative negative, we can prove it is on quadrant 3. So we're going to plot it out. Let's say x is here and y is here. So x is 9 and 12. Now we're going to plot it out. With this illustration, we can see which is the opposite, the adjacent, and the hypotenuse. This is the hypotenuse, the adjacent, and the opposite. We all know that opposite will always be the y, so it's negative 12. The adjacent will always be x. And where can we find the hypotenuse? So we're going to find it. The formula in finding the hypotenuse is c squared is equal to a squared plus b squared is equal to negative 9 squared plus negative 12 squared. Negative 9 times negative 9 is equal to negative 81 plus negative 12 times negative 12 is equal to negative 144. Now we're going to add both. Negative 81 plus negative 144 is equal to 225. Now we're going to square it because there's this one here. Cancel, cancel. The square root of 225 is 15. So that is our hypotenuse. With this illustration, we can see which is for the sine. So sine is equal to opposite over height. So our opposite is negative 12 over hypotenuse is 15. Since we can still simplify this, so we're going to divide it by 3. So negative 12 divided by 3 is equal to negative 4. And 15 divided by 3 is equal to 5. So the answer is negative 4 over 5. The cosine is adjacent over hypotenuse. So our adjacent is negative 9 over 15. Since we can still simplify it, we're going to divide it by 3. Negative 9 divided by 3 is equal to 3, negative 3. And 15 divided by 3 is equal to 5. Since our equation is in quadrant 3, the answer will be positive. So tangent is equal to y over x. So our answer will be 4 over 3. Positive 4 over 3. That will be the answer. The second, the cotangent is the reciprocal of these three. So the cosecant is the reciprocal of sine. So the answer is negative 5 over 4. The second is the reciprocal of cosine.
So, the answer is 5 over negative 3. So, the answer is negative 5 over negative 3. The cotangent is the reciprocal of the tangent.
So our answer is 3 over 4.
This is the answer of the 6 trigonometric functions.